Hi, I'm Mike McDonald from Huawei Technologies. Welcome to Chapter 1 of this course on digital power. First, what do we mean by digital power? If you've guessed that it's about new phone apps that supply electricity to your home free of charge, that's not it. When we talk about digital power, we mean using digital technologies to boost the production of energy from renewable sources like solar panels, or precisely measure how energy is used in order to minimize consumption. It's also about reducing losses during storage and transmission. Or to put it in a catchy way, digital power is about using bits to manage watts. The first human, Homo erectus, discovered fire perhaps 2 million years ago. Since that time, burning things has been at the forefront of meeting our energy needs. We've used fire to warm ourselves, produce steel, power locomotives. Today, almost 2/3 of the global supply of electricity comes from power plants that burn fossil fuels, like gas, coal, or liquid fuels. Most of the world's cars and trucks are powered by internal combustion engines. Overall, fossil fuels meet about 85% of our global energy needs. Fossils have a lot going for them. Natural gas, petroleum, and coal are cheap, abundant, can be shipped long distances, and they release a lot of energy during combustion. But fossil fuels also release a lot of CO2, so much so that it's been creating a planet-warming greenhouse effect. In recent years, extreme weather events, including droughts, superstorms, and catastrophic rainfalls, have become frequent. To reset climate, there's a global recognition that we need to stabilize and reduce carbon in the atmosphere. The landmark 2015 Paris Agreement is a reflection of this consensus, and a majority of large industrial producers, including fossil fuel suppliers, have committed to reducing carbon emissions. How will it be achieved? One approach is carbon capture at source. This involves capturing CO2 when energy from fossil fuels is generated and storing it usually underground, instead of releasing it into the atmosphere. Another possibility is to remove CO2 from the atmosphere. Trees absorb CO2 through their leaves as they grow, so planting more trees is good for the planet. Removing CO2 from the atmosphere can also be done by specialized plants that use direct air capture technology. A few such facilities are being built in different countries. Carbon capture and carbon removal are helpful, but more is needed. The world is slowly but surely migrating towards cleaner sources of power. Wind and solar are steadily taking a more central role. This will be a significant factor in curtailing carbon emissions. Solar is now the cheapest source of electricity, according to a recent report from the International Energy Agency. Rooftops are becoming power plants, and more solar farms are being built worldwide, usually in brownfields, deserts, or floating on water, where they do not displace anything. As solar energy gets abundant, we can anticipate it being used to mass-produce hydrogen by water electrolysis. Like fossil fuels, hydrogen is easy to ship and packs a lot of energy. However, hydrogen only emits harmless water vapor when it combusts, no CO2. In addition to renewables, the use of digital technologies in energy management helps reduce carbon emissions. Using ICT, we can create cities and factories where all devices are connected, where power generation and consumption are measured and managed in real time. At solar farms, newly developed AI can measure the optimal angle for each individual solar panel. Each moves accordingly throughout the day. Smart LED lampposts fitted with motion sensors provide lighting only when needed. Connected power meters report to homeowners in real time how much they are consuming and how much it's costing them. Where they're deployed, smart meters have reduced power consumption by as much as 5%. Transportation is one of the major consumers of energy. Electric engines are far more efficient at transferring power to the wheels than internal combustion ones are. And electric cars can be a source of energy to power the home. How? With AI, they charge when power from renewables is cheapest, usually in daytime. Their battery can be a source of supplementary power at peak demand time, like the early evening. Digitizing everything uses power, but the ICT industry is constantly boosting its energy efficiency. For instance, 5G transmits and receives data far more efficiently, energy-wide, than 4G does. Your smartphone, for example, has more computing power than a mainframe that occupied an entire room 30 years ago and used a lot more electricity and air conditioning. Talking of heat control, data centers are increasingly cooled with natural airflows and liquid cooling. This is far more energy efficient than fans and air conditioning. On the whole, digital power and the digital transformation of industries will have a dramatic impact on total power use. In the next chapters of this course, we'll take a deeper dive looking at how digital technologies can help to make energy greener. Up next, applying digital technologies to power generation.